New topic, implicit differentiation. So if x equals 0, 0, 0, y squared equals 7. Find the derivative and then what? Set it equal to 0, make the derivative equal to 0. Now we have a problem. And this is the new thing. If this equation was just y equals stuff with x, we could say the derivative of y, dy dx, equals the derivative of y with respect to x, all that stuff. So we need another way to find the derivative of this. And that's called implicit differentiation. And the way we do it is just to do it. So to find the derivative, we're just going to find the derivative. We're going to take the derivative of both sides. So on the left, yeah.
To find the derivative to find maximum given point.
Yeah. Find the derivative, set it equal to 0. That gives us where the tangent is horizontal. We have x and y are both variables, so we can't ignore any of them. When we have a multiplication between these, we have to use the product rule. We're going to open up a bracket here using the product rule.
2.
Nope. So hold on, let's call this u.
So you just do dx plus y.
Let's call this uv. Hold on. Okay. Product rule. So we're going to do u v prime. U is x. V prime. What's the derivative of y with respect to x?
dx
Hmm?
dx dy.
No, it's just dy dx. Don't write this down. But this dy dx, it's the derivative of y. It's the rate of change of y with respect to x. So the derivative of y is just simply going to be dy dx.
But why do we need to do times? Why?
If we had...
Do we treat dy dx like it's another variable?
Exactly. It's going to follow just those regular algebra rules as though it's a variable.
What we would do is just say represent, in this case, dy dx just by v or something like that, so then you just
When you're going through these and doing these a lot, you're going to be using y prime. This 2x is going to become minus 2x. This y is going to become plus y.
So I need to find the y?
Well, I want dy dx by itself. I have 2 of them here. I'd really like to have just one of them. Niels, what's the first thing that you would do if you wanted to solve this?
I would, well, look at the top.
Yeah, the bottom, not where we multiply it up, disappears. We have a slight problem. The best we can do is write y in terms of x or the other way around. This is as close as we're getting. This has to be true to the horizontal tangent. And in order to be that tangent, these points have to be on the curve. I could just substitute that y in for this y, and I only have x's.
That's actually smart.
Think of all the math you're doing. 2 apples plus 4 apples. It's all the same thing. We can add them together. 3 apples.
Sorry.
Yeah.
Can I ask you a question?
Oh.
How can you find the max and min from this if it's not like derivative?
So the max and min is going to occur when this is true. Does that make sense? Okay. To find the points where we have to find the points where this is true, but are also on the graph, which means that any x and y that we find has to work in here. So what we're doing is we're taking this, plugging it into here, and what we're going to end up with are the points that this is true, but also this is true.
We could use a calculator or this one, so we can just add this line to our graph and look where it's like.
We could just kind of graph a horizontal line and see where it touches, but the problem is it's going to be hard to get that exact value when you're playing around with those decimals. Anyway, that's it.